Hi, David. How are you?
Hello. I'm fine. How are you?
Good. Excellent. I'm glad you're here. We're excited about having the opportunity to talk with you and ask you a number of questions for our students. So thank you very much.
Pleasure to be here.
We've been discussing the different aspects of information flow in the cell, from DNA and RNA to protein. And I thought it would be a good idea if you could give us some reflections on the central dogma and anything that you could elaborate on, that would be great.
The central dogma is pretty simple. It's basically that there's a DNA molecule, could be in a virus, could be in a cell, could be anywhere, double-stranded, has a plus strand, a minus strand. And that DNA can be transcribed. So transcription is the first process into an RNA, generally a single strand of RNA. Let's call it plus RNA to be messenger RNA. And then that RNA goes on to encode protein by binding to ribosomes. And we have what Francis Crick called the central dogma. It was missing a piece, and that piece is what we discovered and is very important, Howard Temin discovered also. And that is reverse transcription, transcription that sends information from RNA back to DNA. And that allows there to be retroviruses, viruses that cause cancer, or viruses like HIV, which carry RNA as their genetic information, and they copy that RNA into DNA and put the DNA in the nucleus of a cell. The central dogma really enshrines what we learned from the structure of DNA. When we learned that DNA was made of 4 nucleotides, that implied coding, because there's no other way that you could get much information out of 4 units. And coding implies information transfer. And so at that point, 1953, biology became an information science. And ever since then, it's been all about how does the information flow, how is the information coded, what are the units of the information, how many different kinds of codes are there, things of that sort. And utilized by transferring the information to RNA, which is a working molecule, a molecule that's transient but that carries the same information as the DNA has, and allows that information to express itself in protein by a decoding process, which is magnificent and, I must say, one of the great understandings of biological history. And once proteins have the information, then proteins go and do the work of the cell, become the stuff of the cell, and all of the things that we marvel at in biology. So the information is carried from DNA into RNA by a process we call transcription, which is really a very simple mirroring of the structure of DNA and RNA. And then the RNA finds its way to ribosomes, where it's translated into protein.
David, thank you very much. And if you don't mind, I'll pop in again at some other date, some other lecture, to seek your advice. I hope that's okay.
I look forward to it.
Thanks a lot.